welcome back to my channel. This is Pragya Jain and today we are covering a topic of data preparation phases to model the data. First we'll talk about data preparation. Data preparation is process of transforming raw data into the clean or organized data that can be usable format for data science. It is a crucial step in the data science workflow and as it ensures that data is high quality and ready for analysis, modeling, reporting or visualization. Data preparation involves collecting data, cleaning data, labeling data and transforming data. Data scientists spends more than 80% of their time preparing data before using it for machine learning modelings. In this video, we will learn about essential steps for data partitioning, balancing, training sets including CART and C5.0 decision trees in Python. So let's get started. First we'll talk about data partitioning. So the data is partitioned into three sets, that is the training set, validation set and the test set. The training set is used to train the decision tree model, learning patterns and relationships from the data. Validation set used to tune hyperparameters of the model, optimizing performance and preventing overfitting. Test set used to evaluate the final model performance on unseen data, providing an unbiased assessment of its accuracy. Now we'll talk about the balancing class distribution in training data. First is overslamming, underslamming, synthesis minority oversampling techniques. Oversampling, duplicating instance of the minority class to create a more balanced representation in the training data. Undersampling can be referred to removing instance from the minority class to reduce dominance and achieve more balanced distribution. Third one you can say is SMOTE, which is synthetic minority oversampling technique. This generates synthetic data points for minority classes. Now we have CART decision tree, principles and implementations. The CART is classification and regression trees, uses a greedy approach to split the data at each node, aiming to maximize the information gain and minimize impurity. With the use of CART, you can minimize the impurity of your data and gain most of their information. Second one we have is Gini impurity, a common matrix used in CART to measure the homogeneity of the data at which node. Lower Gini impurity indicates more pure node. Suppose we have three data sets and the Gini impurity of three of the data sets are different. The first one has the lowest Gini impurity, so it is the pure node. Next one we have C5.0 decision trees. The advantage of using C5.0 decision tree is to that it can handle missing values and pairing for generalization. C5.0 handles missing values gracefully, using segregate splits to make predictions even when the data is incomplete, and it can pairing for generalization. C5.0 uses pairing techniques to prevent overfitting, simplifying the tree structure and removing its ability to generalize the new data. Now we have evaluating decision tree performance. You can evaluate the decision tree performance on the basis of these four, which is accuracy, precision, recall and F1 score. We have talked about this in earlier videos, but let's take a brief knowledge about it. Accuracy is the percentage of correctly classified instance. Precision is the proportion of correctly classified positive instance among all predictive positive instance. Recall is the proportion of correctly classified positive instance among all the actual positive instance, and F1 score is a harmonic mean of precision and recall and providing a balanced measure of performance. Now the hyperparameter for turning for decision trees are define hyperparameters, choosing turning methods and evaluate the performance. Identify the key hyperparameters such as max depth, min sample, per leaf and the criteria for splitting that influence the model behavior. Choose the turning method. Select the appropriate turning method such as grid search, random search or bias optimization to explore the hyperparameter space. Third one is evaluate performance. Access the model performance for each hyperparameter. Combination using metrics like accuracy, precision and recall that we have learned earlier in this video. Now, practical consideration and the best practices for these data preparation is to that data exploration, feature engineering, regularization and resample methods. Data exploration is that truly explore the data before building a model, understanding features, extracting features and potential relationships of between different features. Feature engineering consists of creating a features or transforming existing ones to improve the model predictive power. Then comes is regularization is the technique for like pruning or regularization to prevent overfitting and empower the model generalization ability. Then fourth one is resemble methods, multiple decision trees into a resemble such as random forest or graded posting to enhance the performance and reduce variance. That's it for the video. I hope you like it. Thank you.